Hey everybody, I want to talk to you about how or what histograms are and how to make them and how to read them. We're going to end up using these quite a lot. Histograms are super handy. They are my favorite kind of graph for displaying quantitative data, and I think they're everybody's favorite kind of graph, to be honest. So let's go look at them. So here's the same data that I was using from the box plot video. Let me delete this histogram so we can start over from the beginning. So here's what a histogram is. Let me quickly make one. They're so common that it's the default. It's the default in sheets here. So here's a histogram. So it's very similar to a bar chart, but it's for quantitative data. And there's a couple of important distinctions between histograms and bar charts. The most important one is the type of data that's in them and what that means. So since histograms are for quantitative data, right, they're just a bunch of numbers, you can't reorder the bars, right? Like if you think about, let's say you have a bar chart of eye color, right? Blue, green, dark brown, whatever's in your chart, you can put blue before green or after green, right? There's no real reason why one should come before the other one. There is a reason why 9.05 here would come before 11.77. It's because 9.05 is smaller, so it appears further to the left. So you can't rearrange the bars in a histogram. They're stuck in the order they're in. You can make them bigger or smaller, but all your bars should be the same width, because the width on the x-axis tells you how many things are going to be in there, right? The wider it is, the more numbers are going to fall into it, and therefore the taller it is. So wider bars also mean taller bars. So you can't have some bars be wider than others, because if they're wider, they'll be taller, and then you can't compare the bars properly, which is basically the whole point of the histogram, is the relative heights of the bars. So here I've got a histogram. This is just some random data. I've got a histogram of that data here. Let me show you how you can tinker with it a little bit. So let me go to customize. The first one I want to go to is the axes. So here's the horizontal axis, and like you can label it differently, make your label look different or whatever. But the thing I'm interested in here is min and max. And the reason you might want to change your minimum and maximum, even though it makes your histogram look a little bit less pretty, is that you might have two histograms that you are comparing to each other, which is the thing I asked you to do on the homework, of course. And one of the ways that you want to compare, or one of the ways that makes them more comparable, is if the min and max are the same. So the scales are the same on the two histograms. So let's just set this one. I just want to show you what we can do. So 0 to 45, right? So there I've set it from 0 to 45, and now we can actually adjust the bar width. Like you can see what the computer has chosen for the bar widths are a little awkward, right? 0, 2.05, 4.09, 6.14. You can see it's going up by, I think, 2.045 each time. I don't want to make it 2.045. How about just 2? So I'm going to go back to histogram up here. And those are called the width of, so each bar is called a bucket. Or it's actually a region on the number line is called a bucket, but the height is, the height of the bar is the number of things in that bucket. So you can change the bucket size to whatever you want it to be. These are a little bit over 2. I'm just going to make them 2. Let's see how that looks. That looks fine. So now my x-axis is demarcated a little more sensibly, right? Every 2 is a tick mark. And you can make them whatever you want. I could make this 3 if I wanted to, or 5, or whatever. And notice that you might notice that these bars are getting taller. I know they don't look taller, but notice this is 200 here. Once I made it 5 wide, but if I make it 2, it doesn't even get up to 100. So yeah, thicker bars are taller. And so that's why you want to make them all the same thicknesses so that they're all comparable heights. Yeah, so you can make the buckets whatever width you want. I hope it's fairly clear what this is saying. This is saying that between 6 and 8, there are however many data points fall between 6 and 8. It's like 100, about 100 data points are between 6 and 8. We can put on data labels if we want to, right? Just like we can in all the other ones, or in all the other graphs. So that's basically histograms. They're bar charts, but for quantitative data, and that means that your bars have to go in the same order. They also have to be, or they have to go in order of where they are on the x-axis, and they also have to be all the same width because the width affects the height. So you have less freedom with with how to arrange your histograms than you do with your bar charts. I don't really want to say too much more about them other than, I guess this is where skewness comes in. I believe we talked about this before in a previous video, but I would say that this data is skewed to the right because all the outliers are over here to the right. And again, if you don't know what outliers are, check out the outlier video. So most of the data is on the left, and then there are outliers on the right that are skewing the mean higher than the median. Yeah, that's why it's called skewed to the right. I don't really have too much more I want to say about histograms other than that they're great. They're the best way to visualize data, or visualize quantitative data, in my opinion. We will use them basically all the time. In graphs that are not precisely histograms, we will think of sort of like histograms, which you'll see when we get a little bit farther, when we get to topic 4 and 5 and 6, and also 7 and 8, a bunch of topics. We're going to use these a lot. So there you go. That's how you make histograms. If you want to, you can check out in your book how to make them by hand. I strongly recommend you never make one by hand. They're terrible. It's a surprisingly tedious process to make them by hand and really annoying. And so I never make them by hand. I just do it all by computer. I would never bother making one of these by hand. And I will not ask you to make one by hand. The way I'll test them is I will ask you to either interpret one, or since you have access to a computer, right, you'll be taking this, you'll be taking the tests online. I could potentially ask you to make one as well, but I wouldn't want to make you type in a ton of data, so I might give you a file. We'll see. I actually haven't decided exactly how I want to test that yet. I will at least ask you to interpret them, so you have to understand what you are seeing, and of course, you know, the bar height represents how many things are in this bucket. So this bar is between 12 and 14. So there were like 60-ish things in this bucket, or in between 12 and 14 in this data set. That's the way you want to think of it. We'll talk about these more in probability distributions, which is topic 4. And with that, I actually don't think I want to spend too much more time on histograms. They're fantastic. You'll use them a lot. But I'm going to go ahead and stop there for now and just see you guys in the next video.